Solving systems using substitution is going to be the second method that we're going to look at. The first method was graphing. Second is going to be substitution. So our target is that we will solve those systems of equations using substitution. So when I substitute things, if you'll remember from vocabulary, substitution is to replace a variable with a number or another expression. So very simply, this is about as basic as it can get, is if I have x plus y equals 8, and I know that y is 5, I can take 5, put it in for y, I'm substituting it in there, so rewritten out would be x plus 5 equals 8. And then I can solve from there. I can undo adding 5 by subtracting 5 on both sides, and so x equals 3. So this is a baby system because I have two equations there, but that would be my solution. The solution would be 3, 5. I know that that is a solution because if I put 3, 5 back in here, 3 plus 5 is 8. Okay, so let's solve a little bit of a bigger system. So here's where you're going to get your exact how-to. Step 1 is to isolate a variable on one of the equations, and so when I'm saying a variable in one of the equations, it doesn't matter which equation you choose to start with, and it really doesn't matter which variable you choose. Now looking at our given system, negative 2x plus 5y equals 19, then I have 3x minus 4 equals y. That's already done for me. Y is already isolated. So step 1 is done for me. Step 2 is I'm going to substitute the expression. I like to think of these as like a bubble. So y is equal to that whole quantity right there, 3x minus 4. Up here, y is just y. So I'm going to substitute 3x minus 4 in for y. So here's what that will look like substituted in. Negative 2x plus 5 times that bubble, 3x minus 4. And then that equals 19. So as you see, let's get a highlighter. Not going to be highlight? Nope, that's not highlighting. There's a highlighter. Y is there. This is the same thing as y. So I've put that in right there. I've taken this bubble and put it in for y. Everything else looks the same. Negative 2x plus 5, negative 2x plus 5 equals 19 equals 19. Now I'm going to solve what I'm calling the super equation. Negative 2x plus 5 times the quantity 3x minus 4 equals 19. I'm going to solve that super equation. When I'm solving this equation, my goal is to isolate the variable, which is x. And so before I can really start undoing what's happening to the variable, you remember we need to clean it up. Part of cleaning up is going to be to distribute that 5. So negative 2x comes down, plus 5 times 3x is 15x, and 5 times negative 4 is negative 20. That equals 19. I can continue to clean this up by combining my like terms of negative 2x and 15x, which when I simplify those is 13x minus 20 equals 19. Then I'm going to undo subtracting 20 by adding 20 to both sides of the equal sign. I'm left with 13x equals 19 plus 20 is 39. Let's make a little more room. Undo multiplying by 13 by dividing by 13. And I get that x equals 3 because 39 divided by 13 is 3. So I have part of my solution. You'll recall from last lesson that the solution to a system is not just going to be one thing there. I'm going to have two numbers because it's an ordered pair that's going to be a solution. So I'm then going to repeat this process to solve for the other variable. So x is 3. I can put x into either one of these equations. Remember, it doesn't matter which one. I'm going to choose to do this equation here, 3x minus 4 equals y, because y is already isolated. If I were to put 3 into this first equation, it would still work, but I'm going to have to do more undoing to isolate y. So I'm going to put 3 into this equation right here. I'm going to draw a line to kind of separate what I'm doing. So that's going to be 3 times 3, because I'm substituting what I think x is into this equation, minus 4, then that's going to equal y. 3 times 3 is 9, and 9 minus 4 is 5. So y equals 5. Struggling with my pen. So my solution is 3, 5. Now we have our special systems again, where you get down to it and you have an untrue statement like 5 equals 2, never true, or you have an always true statement like -4 equals -4. So let's see what those look like when you're solving using substitution. I'm using that same how-to. Do I have it over here? No. Okay. Where I'm going to isolate one of the equations. This one is already isolated, which is nice and convenient. So I'm going to substitute in my bubble. 2x plus 1 is the same thing as y, so I can substitute that in there. So I have 4x minus 2 times 2x plus 1 equals 6. There's my super equation. I'm going to solve it. I'm going to start by distributing that -2. So I have 4x minus 4x minus -2 times 1 is -2 equals 6. When I go to combine like terms, I have 4x and -4x, which combine to be 0, so they cancel, and what I'm left with is -2 equals 6, which is not a true statement, so this is no solution. So something that we can attach from last lesson is, since they have no solution, what these lines would look like graphed is they would be parallel lines because they end up having the same slope. Let's look at our other little special friend. We have x equals -2y plus 4 and 3.5x plus 7y equals 14. The x is already isolated, so I'm going to make that my bubble, -2y plus 4, and I'm going to substitute that in right here for x. So my super equation will read 3.5 times -2y plus 4 plus 7y equals 14. Then I will distribute 3.5, which makes that -7y, plus 3.5 times 4 would be 14, plus 7y equals 14. When I go to combine like terms, -7y and +7y end up canceling, and I'm left with 14 equals 14, which is always a true statement. So what that tells me is that these lines lay on top of each other, and that it doesn't matter what I put in as a solution, it's also going to make the second equation true. So this one is infinitely infinitely many solutions. The reason why it is not all real numbers like you saw in equations is it doesn't mean I can put anything in there. It means that there is an infinite number of solutions, because if you picture that line on the graph, it extends infinitely in both directions.